AutoTech Hackathon 2026. Theme: AI for electric vehicle retrofit and conversion ecosystem. Team: Ekamina. Team members: Ekemini Steven. Theme chosen: brief summary and proposed solution and idea. We title it RetroMind AI, which is we consider it as a self-learning electric vehicle retrofit intelligence network designed for imperfect real-world vehicles. Unlike conventional retrofit systems, RetroMind AI continuously learns from every retrofit performed across workshops to improve future retrofit recommendations. The platform combines computer vision, generative AI, reinforcement learning, digital twin simulation, federated learning, knowledge graph intelligence. The solution autonomously generates adaptive electric vehicle retrofit design for damaged, modified, undocumented, and asymmetrical vehicles common in emerging markets. Impact of proposed solution. The proposed solution will focus on three impact areas: environmental, economic, and scalability. Environmental impact. Retrofit AI will accelerate electric vehicle adoption, reduce vehicle waste, promote circular economic sustainability. Economic impact. It will reduce retrofit engineering costs, enable smaller workshops to participate, expand affordable electric vehicle accessibility. Scalability. It will support scooters, motorcycles, auto rickshaws, cars, and fleets. It is designed for emerging markets and workshops ecosystem. It will continuously improve using collective retrofit intelligence. Our proposed tech stack and architecture. The front end will be using Next.js 14, coupled with Tailwind CSS, 3.js, React 3 Fiber. The AI and backend will focus on Python Fast API, OpenCV for classification, geometry, and deviation detection. Onyx runtime for inference to incorporate PyTorch. Then we have the Skyline, starting from random forest training pipeline, and then we move to Onyx runtime models, and then the PyTorch model. Workers and queues. We use Redis queue and multi-processing workers. The data layer will comprise PostgreSQL 16, Redis 7, Neon4j knowledge graph, which will store our retrofit DNA, look for similarity patterns, and the learning patterns within the data. Infrastructure still under proposed tech stack. All our programs and application will focus on containerized Docker Compose. We will use NetEngineX and Encrypt as a reverse proxy, SSL termination, Oracle Cloud Free Tier, virtual machine with 4 Oracle CPUs, 24 gigs RAM. GitHub Actions with full continuous integration and continuous delivery. PyTorch, specifically using MobileNet v3 for inference, and all these will fall under optional capabilities. We use reinforcement learning, also especially the PPO recommendation agent for battery routing and recommendation. Optuna hyperparameter optimization, OpenAI and Entropic generative refinement. FreeCAD to produce a STEP and STL card 3D models for export in a separate container. RetroMind AI architecture and workflow diagrams. The system intelligence flow will fall into the vehicle upload section that will carry out a structural analysis, constraint intelligence, and move to adaptive retrofit generation. After that, we have the digital twin validation and retrofit intelligence graph. The core architecture layers will include vehicle intelligence layer, constraint intelligence layer, generative retrofit intelligence, adaptive safety intelligence, and self-learning ecosystem intelligence, where our demo will focus more on the deviation-aware battery placement, AI-generated wiring layouts, adaptive card-ready retrofit output. All this system intelligence workflow is captured under the following architecture and workflow. You can see the link. We have the GitHub link to the architecture diagrams, which are much bigger for this presentation. Number one, the architecture falls under 10 categories. We'll look at the deployment topology, the component architecture, the full assessment workflow, the job state machine, assessment stages that will span progressive disclosure. Number 6, confidence engine decision flow, the database schema and element relationship, degradation tiers, infrastructure degradation flow, and API map. Continuing on RetroMind AI architecture and workflow diagrams, the deployment topology will contain Docker services that will span PostgreSQL, Redis, Neon4, API, Worker, FreeCAD, and training scheduler for all the AI models that will be trained within. Number 2, the component architecture, Next.js front-end page through component and hook structures and backend API and services layers. The full assessment workflow will have an end-to-end sequence from authentication through intake upload analysis that will comprise up to 11 stages, confirmation and report. Job state machines. Job lifecycle states will be having a queued job that's running up to completion stroke failed and transitions. Assessment stages, progressive disclosure, breakdown of each analysis stage and what output it produces. Confidence engine, decision tree that combines heuristic, model confidence and degradation tier to determine final state. Database schema, ER diagram showing intake, job, assessment, and related tables with foreign keys. Degradation tiers, you have 3-tier degradation system with per service impact on features, infrastructure degradation flow, how failures in Redis and Gen AI and reinforcement learning propagate through the system. API route map, all REST endpoints grouped by authentication scope, which will be public, workshop, card, admin, and V2. Since the architecture diagrams are very much bigger than what we can present here, we look at the deployment architecture, which is what can go into one of our presentation slides here. We have the workshop user and the platform administrator that flows through the Oracle Cloud Free tier virtual machine with 4 Oracle CPUs and 24 gigs RAM. Passes through Nginx proxy, reverse proxy to the back end, while the back end and the front end are staged behind Nginx, a reverse proxy. So we have the front end feeding directly from the backend, where the backend feeding directly from the Postgres, Redis, and Neon4 uh, databases. We have the worker as a multi-core processes and concurrency that feeds from what the user uploads the images of the vehicle from the front end, and the section that runs the entire AI models comprises of the Onyx runtime, OpenCV, PyTorch model, and so on. Then we can jump to architecture 4, where we have the job state machine architecture diagram. We know it's a queued kind of job. Worker the queues on running. If there's a failure, we have a retry section. If it's completed, we go right to the end of that particular job. The RetroMind AI landing page. This is the screenshot of the landing page. As the user logs in, this is the first page, what we call the onboarding page for the user, that shows you through uploading of your vehicle images, a vehicle classification by the AI models underneath, the deviation analysis. The AI measures the geometry parameters and detects deviation from reference standard, which is actually the OEM, the vehicle OEM specification for that vehicle. The battery and wiring optimization, having a spatial constraint solver that select optimal battery zones and wiring routes based on vehicle geometry and detected deviation. Compliance report, you have a 13 section compliance report with visibility score. From the landing page, the user is faced with a new retrofit assessment page, where the user uploads the first 3 images. The left side, the right side, and the rear side is compulsory, while the remaining 3 comprises of the front, the engine bay, and the underbody section is optional. We also have a section for loading a demo vehicle. This is particularly for new users that want to quickly experiment the function of Retrofit AI, retrofit assessment, without having to upload their own vehicle images. We have the compliance report section that span the result of a particular retrofit that has been carried out. Here we have the setting page, where the user is displayed, the section for the user to change the API key for security purpose. We have a section for selecting optional capabilities by the user, which comprises the IP parameter optimization, the PyTorch convolutional neural network classifier, reinforcement learning adaptive recommendation, generative AI refinement, and the free card export for the digital twin 3D model generated. The section for assessment history page, where you have the assessment history that comprises of all the retrofit jobs that have been carried out by all the workshops that have been registered under RetroMind AI. Here you have the vehicle that was identified by the AI. You have the status, if it was completed, the job was completed, the compliance, was it a pass compliance, was it a fail compliance, or was it passed with caveat. We have the confidence level that the assessment have been able to prove that that conventional vehicle can be converted to electric vehicle. We have the visibility section that actually tells you it is visible for adaptation, it's not visible, and so on. Then we have the knowledge graph page, where all the retrofit that has been carried out is stored, and their relationship to each other. Then we have the section for analytic page where we can check workshop analytics and check the total number of jobs that have been carried out by a particular workshop, how many has been completed, what was the confidence, percentage confidence, the hours and the time that has been spent. We have the top deviation, where you can find out what particular section of the vehicle has top deviation. As we can see from the screen here, we have the frame left rail. The rear cross member of the chassis of the vehicle has more of the deviation after assessment by RetroMind. And finally, we have the admin dashboard where the user will key in their API key to have a full matrix of how many workshops, how many intakes have been carried out, the total jobs, the ones that are completed, the ones that timed out, those ones that are active. Then we have a section for all the lists of workshop, all the list of users. Then why do we say our solution must be considered? RetroMind AI solve the real-world challenge most retrofit systems ignore, which in real life we have mostly imperfect and modified vehicles, which is quite different from standard factory vehicles. Our main differentiators will be a self-learning retrofit intelligence network, deviation-aware engineering AI, retrofit DNA and knowledge graph, federated workshop learning, lightweight AI retrofit digital twin. The platform transforms electric vehicle retrofitting from tribal workshop knowledge into scalable collective machine learning intelligence. Additional information. The GitHub repo for our project can be found on the link displayed here in the presentation. For our future expansion, we hope to key in predictive maintenance intelligence, real-time retrofit safety monitoring, AI-assisted compliance certification, fleet-scale retrofit analytics. Our main vision is to become the fundamental intelligence infrastructure powering next generation of electric vehicle retrofit ecosystem globally. Watch our demo at this YouTube channel. Look at the link below. For us, RetroMind AI is a self-learning electric vehicle retrofit intelligence network. Team Ekamina ET AutoTech Hackathon 2026. Thank you.